Okay, I want to talk about these Altech smart relays. They're available at Allied Electronics and then I think various other places online. I've used these for about 5 years now in some pretty harsh environments, temperature ranging really from 0 to probably 140 degrees Fahrenheit. And I have not yet changed out any hardware. So for the price point on these are very good for the money. So they're relatively easy to program. You can make them a standalone unit. You could learn to program these in one afternoon. And all you need to do to get the software, it's free software, is go to this site here, altech.com, Smart Relay, and download this software right here. Once you download that and you install it with your wizard, you will have the ability to open up their programming software. And it will look like this. So today, all we're going to really do is set up a basic stop-start circuit, add some comments, use output coils and inputs, and then we'll advance from there slowly. So you can see on the very top here, you have view. Believe it or not, this one tab here is where you can do a lot of your work. Go into parameters and comments here, and you can go ahead and make up what your inputs are going to be. I think we're going to want a start push button. I'm going to call that input 1. Input 2, I think, is going to be stop push button. We're going to also have an e-stop. I think we should have some feedback from the contactor that's telling us that we're running, so we can make an indicator light or something. So I'm going to call that M contact aux. For the auxiliary contact. And then we should have some sort of overload feedback to tell us if we have a fault, tripped overload, for example. So we're going to call that overload aux, auxiliary contact on the overload. And then we will apply those and then go to output. The output, we want an M contactor. So assuming we're doing a motor starter or some sort of inductive load. And then let's have a fault light. Fault indicator is what I'll call that. And let's have a running light telling us that we're running. Let's apply those. All right, I'm going to close this tab. Go into the cues there. There's my outputs. Go back into my inputs. You can see that I have all these inputs. Now let's put the e-stop in first. All you do is select it there. You highlight it. Go over here. You can kind of see the contact show up. Now it shows up as a normally open contact. In this case, let's make it a normally closed contact. Now you see how that's ladder logic. You can also change that up here in edit mode under the view tab again. Edit mode, as we're selected as PLC right now. If you wanted to show that in a different type of contact, you could show it as a switch hitting electrical here. But that's not what we're trying to demonstrate. So I'm going to go back and put it in PLC. Okay, now let's add our start. So we just highlight that, come over here and drop it in. So now you have an E-stop and a start PB. And let's put a stop PB in, again, highlight it, drag over, place. Now I think we need to put our output coil here. So let's go back into the outputs, which are labeled as Q here. Select the Q, Q1 for M contact, and drop it in. Now I want to put a set of contacts around this start PB to hold this in and do what's called latching it in or sealing it in. I'm going to seal it in by using an auxiliary contact on this. So I will go back into these inputs here just for kicks. I will drag this over here, place it right there, connect that with a rung, connect that with a rung, get rid of this. There. So what we're doing here is sealing this in. I'm going to make some comments here. If the E-stop is not pressed, and stop is not pressed, and start is pushed, run M. Now, I'd like to also change this to normally closed. Now, I didn't put any lights in here yet, but let's go ahead and check this, make sure that it operates the way we intend. And we can do that by going up to simulation here. And we're going to simulate it with the PC. When we do that, you can see that it gives us the ability to turn on and off the status of these inputs 1 through 8, and then the Q outputs 1 through 4. Right now, we don't have anything active because we didn't push our start PB. But let's go ahead and test our E-stop first. Open that up. And now let's push our input number 1 here for the start PB. And nothing happens. Okay. So let's put that back in steady state. And let's push input 1. And then you see Q1 comes on, M contactor comes on. But let's let go of that input. And we can see that it stays latched in. And continue to run until somebody pushes the stop or somebody smacks the E-stop button. So let's go ahead and push the stop button to verify. And there you go. So I will stop that. Now let's add a run light. We go back into our inputs, and we're going to take the M auxiliary contact here. Now you could use another auxiliary contact right off of this contactor to run this run light, but I want a field device to know that it's actually coming in out in the field. So that's actually going to be a digital input going to input 4. And I also want to put an overload contact, and I'm going to call this one is going to end up being a fault indicator. Is that Q2? Place that there. So this is overload fault. And I made that normally open. I'm going to leave it that way. This as well. Generally, when you buy these, you can pick whether you want it to be normally open or normally closed. You'll have an option, but it's very easy to change it in the program. Motor running. Okay, now let's simulate this. This will be a simple start circuit with an E-stop, a latch in, and a regular stop PB with a running light indicator, and with your overload here, a fault indicator. We're going to assume that the overload is wired in series with the contactor in the field, and we'll drop that out. But we could very easily run this as a normally closed contact right here in series with the stop PB and the E-stop PB, and drop it out that way as well. So with PC. Okay. Now, as soon as this comes in, I'm going to have to physically force this in to show that this would normally come in with the M contactor. And we'll drop that back out. Oh, this would normally come in with the M contactor. It would stay in. Then this would be a fault indicator that would trigger if we dropped out the overload. But as a result, that would likely drop all this out because this would unseal itself as well. So we'll simulate that by putting up the E-stop. And then we'd have a steady state fault indicator. So that is a very basic program. You see how quick and easy you could be up and running with this this Altech Smart Relay. So thanks for watching, and I will add more videos.